Imagine a summer night. You are standing on the grass surrounded by darkness. Suddenly you see some twinkling lights floating in the air, just like stars scattered from the sky. And this must be the firefly, the most well-known bioluminescent organisms. Speaking of luminescence in the biological world, people always first think of fireflies. But in addition to this insect, bioluminescence is widely distributed in nature. In fact, of the 25 phyla in the animal kingdom, 13 phyla and 28 class of animals have luminescence. Most bioluminescent organisms are found in the ocean. There are luminous animals such as dinoflagellates, marine worms, deep-sea fish, and so on. Except of the light emission of the animal itself, there are also many examples of secondary light emission caused by parasitism or symbiosis. For example, the midshipman fish feeds on a tiny seed shrimp which is luminescent. After eating them, a chemical reaction begins that leads to bioluminescence. After seeing all these amazing creatures, you probably already understand what bioluminescence is. Bioluminescence is a compound word, which is a combination of bios, means life in Greek, and lumen, which means light in Latin. Bioluminescence is the production and emission of light by living organisms. But you may be still wondering, why were these creatures luminous? Dividing carefully, there are two types of luminescence. One is passive. For example, the thin dry light of plants is just excess light that has not participated in photosynthesis. And the general view is that this kind of light is meaningless. The other one is active luminescence. It is used by living things to hunt prey, defend against predators, find mates, and execute other vital activities. The chemical reaction that results in bioluminescence requires two unique chemicals, luciferin and either luciferase or photoprotein. Luciferin is a compound that actually produces light. In a chemical reaction, luciferin is called the substrate, and luciferase is an enzyme. An enzyme is a catalyst that interacts with a substrate. The interaction of luciferase with oxidized luciferin creates a byproduct called oxyluciferin. More importantly, the chemical reaction creates light. And this is a space-filling model of firefly luciferin to help us understand its mechanism of action. Here's color coding. Most bioluminescent reactions involve luciferin and luciferase. Some reactions, however, do not involve an enzyme. These reactions involve a chemical called photoprotein. Photoproteins combine with luciferin and oxygen, but need another agent, often an ion of the element calcium, to produce light. Photoproteins were only recently identified, and biologists and chemists are still studying their unusual chemical properties. Photoproteins were first studied in bioluminescent crystal jellies, and is called green fluorescent protein, or GFP. And this is Japanese organic chemist Osamu Shimomura. He received 1/3 of the 2000 Nobel Prize for Chemistry for his identification of GFP. And nowadays, bioluminescence plays a very important role in all fields of human scientific research, such as disease study, warfare, and pollution detection. From the earliest discovery of bioluminescence to the present, it has not been a long time, and the human exploration of it will be endless. In the days to come, let's approach this mysterious phenomenon together. Thanks for listening.